Oh, before I start today, little reminder of something we did in the last unit. Let's see if anybody remembers. Other than 2, 3, and 4 adding up to 180 degrees, can you give me any other theorem that I showed you guys at the beginning of last unit? All right, there is a little theorem I had you. You'll notice I threw a little exterior angle at you there. All right, Nick, what do you got? It's okay, I'll help you out. Just name the angles at least. Darn right. Angle 1, the exterior angle, is equal to angle 3 plus angle 4. For a little bonus here, anybody remember the names of 3 and 4? Remote interiors. Perfect. All right, so the exterior angle is equal to the sum of the two remote interiors. Why do I ask you to remember and review that with me? Here's what we're going to do today. Well, if angle 1 is equal to 3 and 4 added up, shouldn't angle 1 by itself be bigger than which angle? Well, I don't know that. No, I don't know that. If angle 1 is equal to those two put together, angle 1 should be bigger than both of those individually. Everyone agree with that? That if I have, the only way I'm getting 1 is if I put 3 and 4 together. If I separate them, angle 1's got to be bigger than each of them. All agreed? Okay, there's your first theorem for today. All right, the exterior angle of a triangle greater than either of the two remote interiors. So using my diagram, I need help right now. Using my diagram, name the exterior angle up here. 7? DCA, thank you. I know DCA has to be bigger than, name a remote interior now. Here you go, 8, name a remote interior. CAB, I'll call it angle A. And not only is it bigger than angle A, DCA should be bigger than the other remote interior, which is angle 19, angle B. Yep. Some of you guys may have just made this mistake. I cannot tell which one's bigger, the exterior or the linear pair or the linear angle next to it. I do not know which one's bigger. Don't make that mistake. I have no idea, but I do know this one's bigger than A and this one's bigger than B. All right, let's roll. Let's use that theorem now. I want every single angle that's bigger than 7. Bigger than 7. And here's a challenge to you. There's 5 of them. Can you find all 5 without me poking and prodding you here? All right, take a look at 7. It's outside, right? So right now, name a triangle. Angle 7 is an exterior angle for. Angle 7 is an exterior angle for what triangle? 9, go ahead. What was the question? Okay, angle 7 is an exterior angle for what triangle in this diagram? Because there's multiple answers. ML, there's no S up here.
Oh, that's okay.
MLK? Everyone agree with this statement? Angle 7, exterior angle for that triangle. Yes, which means that angle 7 is bigger than the two remote interiors for that triangle. Name the two remote interiors for triangle LMK. If I could talk here. Here we go. What do you got for me? 18. 7 is an exterior angle for what two remote interiors? So it must be bigger than angle 5. And what was the other one, Hugh? Angle 4. Everyone all right? Okay, but angle 7 is an exterior angle for another triangle in that diagram other than the one Justin just gave us. What other triangle is it an exterior angle for? Take a look. 8. Good man. LJK. Let me highlight that sucker. There it is. Name the two remote interiors for that triangle now, because 7 is going to be bigger than those two angles. So 3, 4 here. What do you got for me? Name the remote interior. 7. Angle 7 is a remote interior for angle 3. Got it? And you're probably going to have to use 3 letters for the next one. It's remote interior with angle 3, and where's the other remote interior? So JKL, everyone see that? JKL? But didn't I say there was 5? Where's that 5th one? Because we've gone over every single remote interior we could for every single triangle. Where's this other one? What's up, Sean? Woo, we got a winner. You want to explain to your classmates how you know angle 7 is definitely bigger than angle 2?
Because angle 7 is already bigger than JKL and angle 4. So JKL minus 4. I don't know what I'm saying here, but
you're in the ballpark at least. Here's what he's trying to get out there. Angle 7 was bigger than JKL. Everyone agree? How's JKL made up? So shouldn't it be also bigger than the 2 angles it's made up of? Which would be 4, which we have already, and 2. All right, everyone good? All right, let's flip it on you now. Give me all angles greater than 6. All angles greater than 6, and I only could find 2 of them. But all angles greater than 6. Well, let's start here. 6 is an angle in what triangle? Give me one triangle, angle 6 is an angle in. Here you go, 18. JK, oh, going the big one, you got it. Everyone agree? So now what I got to look for is 6 inside or outside. So is there any exterior angle that angle would be bigger than 6? Do you see any exterior angle? And I can't pick 7, because remember what I said, when they're linear pairs, I don't know which one's bigger. Is there any other exterior angle that's drawn in this diagram where 6 would be a remote interior? Do you see any other exterior angles up here? Hey, 9, do we see any more? Angle 8, got it. And for that triangle, I don't see any other exterior angles. All right, but name another triangle angle 6 is a part of. What other triangle is angle 6 a part of? Here you go, 18. Yep. This one's a little tougher to see. Still, 6 and 7 can't tell me anything. Is there another exterior angle for this triangle I've highlighted where 6 would be a remote interior? It's there. Find an exterior angle to this triangle where 6 would be considered a remote interior. Here you go. Let's, got me there. Nope. Ooh, I'm getting rattled now. There we go. What do you got? 1. That's what I said. Oh, 1. Get it? Angle 1. Yes, everyone see exterior angle? If I kept extending this out, 1's an exterior angle, and that means 6 would be a remote interior. Questions? All right. Let's see how good you are right now. This one's a tough one now. I'm going to start it, and I want to see if you and your group can end it here. AB is congruent to BC. Everybody stop right there. Is there anything else you can mark on that diagram that you know is true because AB and BC are congruent? We just did an entire unit on that. What else is true, 7? If those 2 sides are congruent? Thank you very much, BCA. All right, that's all I'm going to give you right now. Look at the choices. It's got to be a definite yes. If it's a maybe, I can't count it as being true. So which one of those 4 are true? You got about a minute and a half in your groups. All right, let's not waste any more time. Let's get right to it. Choice 1 says 1's bigger than 2. Well, I can tell you right now, I can do this to you. 20, 20, and that's what, 140 left over? Could be. So is 1 bigger than 2? It could be, but not necessarily. Go on. 1 bigger than 4. All right. Well, here's 1. Here's 4. Everyone take a look at that triangle. What type of angle is ACB? For this triangle right here, what type of angle is ACB? That is? So you're telling me that angle ACB should be bigger than angle 4, correct? What do you know about angle 1 and angle ACB? So if ACB is bigger than 4, so is angle 1. If you don't have them out already, let's get those calcs out for me. If you don't have them out already, let's get the calculators out. Okay, here we go. So we know an exterior angle is bigger than either two remote interiors, and I got one more triangle theorem for you. And I really don't want to give it to you. I have faith somebody in here can come up with it. I do. I have faith somebody can. So what I've given to you is 2 different triangles. I've given you the 3 sides of each of them, 2 out of the 3 angles, and I want to know where's the pattern. What's the pattern between both of them? All right, and some of you are going right to the calculator. That might be a good idea to find that third missing angle. All right, so I'll give you guys about 2-3 minutes. Look at it by yourself, talk it out with your teammates, and see if you could see any pattern between both of those triangles. And there is a reason I have given you all 3 sides and all 3 angles. That's where I need your focus to be. So see if you can come up with any pattern. So after finding the missing angles, you guys want to try to, this should come out great.
So where the largest side is, that's where the smallest angles are, you know? That was the one he came up with. But it's the same thing on both triangles.
Okay, we said the longest base. So like for the triangle on the right, it'd be 25. Could be like, what is that? You got it. You got it.
Okay, so across from the longest side is the biggest angle.
Okay, out of that, what was that, about a minute and a half we could have got back of our lives, Will finally comes up with the pattern, and he is correct. Take a look. Which one's the smallest angle up here? It's across from the smallest side. All right, same thing over here. Smallest angle is 35. It's across from the smallest side. Largest side across from largest angle. Yes, Hugh. Everyone, say goodbye to your IQs. Go ahead.
For each side, when you add like these 2 sides together, like when you add these sides together for each vertice, whichever number is the smallest, that is the biggest angle. I don't know why, but it works in both of the triangles.
You could have said that in Greek and I would have understood it better, maybe. I have no idea what you just said. So say 4 plus 5.
4 plus 5, that's 9.
Yep, usually that's how it works.
Their angle is 82.
Okay. I'm still waiting for the fireworks here.
7 plus 4 is 11.
Yep.
And that's 56.
How is 11 connected?
So where are
We
they?
should get an
Where
11.
I wonder if he gets rubbed on his head.
11 is 56.
I have no idea.
Oh, I get what you're saying.
What?
Wait, shit.
And that works in both of them. That could just be completely random, but it works in both of them.
You just said 4 plus 7 is 11, and the angle's 56. I don't know how those two relate, though.
I can't really explain it.
I think that's the only thing we got out of that conversation. Yes. All right, so here's what the 2 theorems we just said. In a triangle. And this only works when you're looking at one triangle. You can't go from triangle to triangle, all right? In a single triangle, smallest side across from smallest angle, always. And theorem 2, I'm just going to write the reverse, which is smallest angle across from smallest side. So in a triangle, smallest angle across from smallest side. Okay. So what I'd like you to do in your group right now is go ahead, try 1, 2, and 3 out on the next page. Okay, if we get to number 4, we get to it. If not, that's fine. So go ahead, 1, 2, and 3 on the next page. I'll put my work up here as well so you can see how you're doing. Before you start anything about comparing the sides, you're going to need all 3 angle measurements. Yep, before you start anything. And these diagrams not drawn to scale. And again, shortest to longest. Once you have 1 and 2 correct, you've checked your answers up with mine here. Go ahead and try out number 3. 3 requires a little bit more work. Everybody good with 1 and 2? Okay, most of you guys are on 3 now. What are you doing with angles A, B, and C that they give you? Are you? And that's it? Good job, Michael. Equaling them to 180. As you set up and solve your equation, hopefully you're getting x is 20. What are you guys getting for angle A? 60. How about angle B? And angle C? Okay, going through the choices, is this isosceles? No, if it was, 2 out of the 3 would be congruent to each other, angle measurements, which they are not. Is AB the longest side? Well, if AB is the longest side, that must mean angle C is the biggest. Yes, no? It's not the biggest. AC, longest side. So if AC is the longest side, that means angle B across from it should be the biggest. And is it? Yes, it is. So since angle B is the biggest angle, AC is the largest side. Everyone all right? Okay, let's see how much we can get through this next one, because this is a little bit more of an enriched problem. Find the longest. I'm going to change it up on you, because I want to make it even more enriched. I don't want to find the longest. I want to find the shortest. Make this a little bit more difficult. Probably before we even start talking about shortest, we should probably fill in what? The rest of the angles, right? So we can start comparing everything. So go ahead, find the missing angles. 180 degrees in each triangle. For angle ADB, what are you guys getting? 60. And how about for angle CBD? 57. So now I would suspect most of you would say, oh, you want the shortest side in that diagram? Where's the smallest angle in this diagram? 53, where's it across from? BD, there's my answer. No. That's the smallest side in triangle BCD. I'm asking for the entire diagram, though, so I can't pull that off. Here's what I want from you, though. How many triangles are in the diagram? 2. 3?
Never mind.
Okay. It's all right. We saw an extra one there for a second. So here's what I want you to do. Take each triangle and tell me from shortest to longest the order of the sides. So let's start in ABD together. ABD, what's the shortest side? AD. Next one. AB, and the largest side. BD. Let's go over to BCD. BCD. BD. Next one. CD. And what's the longest side? BC. So you guys that are telling me, I'll finish it up tomorrow after the quiz. See if you can finish it up too, now that you know all the facts here.